Welcome back. In this lesson, we're going to look at how groundwater can actually dissolve the earth, dissolve the rocks, dissolve the stones, and then deposit what was dissolved in that water somewhere else. So a lot of this has to do with acid precipitation, and so we'll look at how that's formed and then how it works. The thought of acid pouring down out of the sky on you would be a nightmare, but it actually happens every time it rains. Water is so reactive with carbon dioxide in the air. So carbon dioxide is expelled when you breathe. So you take in oxygen, and one of the waste gas that you produce in each of your cells is carbon dioxide. So when you breathe out, a lot of that is carbon dioxide. That carbon dioxide can react with the water, just the vapor in the air, to form a weak acid called carbonic acid. And that acid is now capable of reacting with normally some kind of a carbonate. So any of the stones or rocks or minerals in the ground or on the ground, or statues or tombstones or whatever would be made out of these, like limestone or marble, this acid can react with it. And acid on a carbonate is just like vinegar on baking soda. It creates carbon dioxide gas bubbles. And what will end up happening is that the rock then dissolves. It dissolves in that acid. So if you have a little bit of acid sprayed on a limestone and it bubbles even just a little bit, you're going to have less stone than you used to. Well, if the rain has acid in it, and that comes from like natural sources, but also it's made worse by pollution. So if there is, say, sulfur dioxide or something from smokestacks or from a car in the air, then you can actually make several kinds of acid. You could make sulfuric acid, and it could be pouring in the sky during the rain. So any of this could have reactions to these stones. So here's a picture taken, 50 years before the second one. So this is, you can see, in a gritty industrialized city that has lots of air pollution. And then over that time, all the features of that limestone statue has been eaten away. Even you can't even tell where her arms are. So that is called acid rain. It's not just rain, of course. It can be snow. You can have acid in snow. You could have acid in the sleet, whatever. And it's going to react with stones. Now, the stones are not just on the surface of the earth. They could be in the earth. So the water that contains this acid percolates down through the aerated layers of the rock down into the water table, and then as it is following along cracks within limestone rock, it can eat it away. And it is possible that even a solid piece of limestone, an enormous mountain of limestone, over time could be eaten away, and you'll end up with a cavern. And we'll look at that in just a second. So the cave is when you have an access point to the outside. That's a cave. Cavern normally is a chamber, underground chamber. And most of these underground chambers have been eaten away by the acid, essentially dissolved. So you have a huge block or enormous mountain block of limestone, which is a carbonate, and then you have little drips of this water that has acid in it. And then little by little by little, over time, that acid eats away that stone. And then as it's dissolved, then it has to go somewhere. So you get all these beautiful drip formations, dripping from the ceiling, just like an icicle would, only as it's dripping, that water is containing the minerals that used to be the limestone, and so it takes it with it. So as it's dripping, the water could then evaporate and then leave a little dab of that mineral, and you end up with essentially an icicle made out of limestone. So what used to be just a solid block of limestone is now a chamber, but not just a chamber with walls and floors and ceilings, but dripstone all over the floors and ceilings and walls. Pretty cool. So what's happening is that this limestone isn't a solid block. There's cracks in it. There's faults in the rock. That rock is not impervious to the forces of the earth. So as the earth is kind of banging around and moving, which it is moving on a very slow kind of global scale, it can crack these limestones, and then that stone has a crack in it. That's where the water will get in. And then if the water sits on something, it sits on, say, a ledge or surface, it's easy for it to start eating it away. Once you end up getting holes underground, then it's possible for water to then pour into these holes. Now that's called a sinkhole. If you have an access point to the surface that's large enough to fall in, that's called a sinkhole. And sinkholes can be really dramatic. A couple years ago in the Corvette Museum in southern Kentucky, and that's so much limestone. All of the understructure of southern Kentucky is made out of limestone. Some of the biggest cave systems in the world are in that area. And so there are lots and lots of these sinkholes where there's chambers underground and you don't even know they're there. And one developed underneath the Corvette Museum, and a whole lot of priceless Corvettes fell into the sinkhole. It made the news. So sometimes then you end up with water pouring in that then has to somehow find a way out. And you can end up with underground rivers, which is pretty cool. Now the topography of this material, so the topography is the way the land is shaped. Any kind of land that's shaped by the acid that's eating away at this limestone is called karst. So I think this picture is from China. This is a karst topography where the ground used to be at the top of all that layers of rock, and then as it was eaten away, basically it's pitted that entire section, and now you have these big, sharp, Chinese-y looking mountains, which is pretty good. That's called karst topography. And then I would imagine that some of you actually know this. The dripstones have names depending on where they're located. So if it comes from the ceiling, it's stalactite. And then if it is on the floor, so if that water that contains the mineral drops on the floor and then the water pours off and the mineral sticks, and then you build a column from the bottom, that's called a stalagmite. So stalactites, and I think of tight against the ceiling. The icicle is tight against the ceiling. That's stalactites, and then stalagmites.